Okay, so let's talk about using algebra tiles to solve quadratic equations. I want to start off with a really simple one. So let's start off with solving x squared equals 9. I can't remember if if you read about this one in the textbook or not, but you probably read about something similar to it anyway. But let's do x squared equals 9. So um, here's how we would represent this with algebra tiles. Okay. So we need to give ourselves an x squared tile for the left-hand side. And on the right-hand side, we need 9 units. Seven, 8, 9. Okay, so I've got 9 units there. Some of them are sitting on top of each other, but okay. So remember, our goal here is to solve for x. We want to know what x equals. And right now, it doesn't seem like we have any x's on the page. But actually, if you think back to when we first introduced algebra tiles, we talked about how the value of the tile is the area of the tile. So this is an x squared tile because the area of this tile is x squared. Well, how is the area x squared? Well, the area is x squared because this width is x and this length is x, right? So the area would be x times x, which is x squared. That means that this represents x right here, right? One of the sides of the tile represents x, or along the top of the tile represents x as well. That kind of gives us a clue as to how we're going to find the solution to this equation, because what we need to do is arrange the unit tiles so that they are also in a square, like the x squared tile is. So I'm going to ever so carefully set them up into a nice 3x3 grid. Okay, this 3x3 grid, notice that the length of the grid is 3, right? Each of these is a unit, so it's 1 plus 1 plus 1, so that's 3 across the top and 3 down the side. So clearly x must equal 3. Or another way to see it, x equals 3, right? So once you arrange it into a grid, you can see pretty clearly that, you know, the stuff along the top equals this stuff here along the top of the other square, or the same way going down, right? So in order for this to work, you have to get the units on this side to be a square, and actually you have to get both sides to be a square. So so let me write down the solution, right? We would say, okay, well, if this is an x by x and this is a 3x3, then clearly x must equal 3, right? So you see the solution along the top or down the sides. That one is pretty obvious. You might be kind of shaking your head like, what is the point of this? You know, let me give you a slightly more challenging one. So let's do x squared minus 4x plus 4 equals 25. Okay, so I'll give you a second, pause the video, see if you can represent the left-hand side and see if you can represent the right-hand side. I'll say this, I'm not going to sit here and count out 25 tiles. I'm just going to draw them. I'm just going to draw a box and make it a 5x5 grid. Okay, but the left-hand side, see if you can use your tiles to represent that. Here's how this is going to go for me. So I've got x squared. I need 4 negative x tiles, so I'm going to grab 4 red x's. and then I need to grab 4 positive units. Okay, so that's just the left-hand side. Now, in order to get the answer to the equation, we have to get the left-hand side arranged into a square. Okay, so your goal is to take these tiles that you've laid out and arrange them into a square. So if you haven't achieved that yet, pause the video, see if you can arrange these tiles into a square. Okay, I'm going to show you a couple different ways that you could potentially do it. Okay, so one way to do it is you could maybe put x squared there in the middle, put an x along each of the sides, and then fill in each of the corners with a unit. Okay, and now you've got a square on the left-hand side. On the right-hand side, like I said, I'm just going to draw in 25 squares instead of having to count them out. I'm just going to draw 25 units. Okay, so there are my 25 units, right? Okay, so that's one way that you could do it. Let me show you another way that you could set it up. So another way that we could arrange the tiles into a square. And this is kind of like the way that I'm going to do it most of the time. I'm going to start off with x squared. I'm going to put that in the upper left-hand corner. Then the 4x, I'm going to split into 2's, right? So I'm going to put 2 of the x's along the side here. And I'm going to put the other 2 x's down on bottom here, going in the opposite direction. And what you'll notice is that that leaves me with this cavity right here, which just so happens to be 4 square units, right? So I can fit my four unit tiles in there to form a square. Okay, so that's another way that you could arrange the tiles into a square, and this is how I'm going to do it most of the time. Okay. And in fact, if you read the little spiel that I wrote before you watched the video, then you know that we're talking about completing the square, and to complete the square, you do b divided by 2 squared, and you might wonder, you know, where that comes from. You can kind of start to see that now because we took the middle term, which was a -4, and we split it into 2, right, to get 2 there and 2 there. And then notice that 2 squared is 4, right? That gives you the number of units that you need in order to complete the square. We'll talk about this a little more as we go on. Let's just finish solving the problem now. So the question is, how do you get an answer here? Well, we know that this is a 5 by 5 grid, right? You've got 5 units going along across the top. If you had to describe what the top was over here, and let me shift my tiles down so I have some space to write. But if you had to describe this edge, just the top edge, right? So think about the lengths involved here. The length of the blue tile from this corner to this corner is x, right? The length of the red tile from this corner to this corner is -1. And the length of this tile is also -1. So along the top, we have x minus 2, right? This is x minus 2 along the top. It's also x minus 2 down the side, right? So in either case, you can see it must be the case, right, that x minus 2 equals 5, right? Okay. So you add 2, and then you get x equals 7, and there's a solution. I guess I shouldn't say the solution because there's more than one, right? And in fact, I need to go back and amend the first example that we worked out together when we were talking about x squared equals 9. So let me put the tiles back on there. All right, so we have this scenario. We said, okay, so x squared equals 9. One possible solution is x equals 3. We never talked about another possible solution, though. Well, if you think about it, one way to get a bunch of positive tiles over here is to have a positive times a positive. But another way to do it is to have a negative times a negative, right? Negative 3 times negative 3 would also give you positive 9. So another possibility is that x equals negative 3, right? So x equals negative 3 is another possible solution. So going back to the problem that that we were working on a second ago, x squared minus 4x plus 4 equals 25. One way to see this is to see it as a positive 5 times a positive 5 to get a positive 25. Another way to see it is to see it as a negative 5 times a negative 5. That would also give you a positive 25. And so another possible solution is that x minus 2 equals negative 5. And then you finish solving that one, so you would add 2 to both sides, you get x equals negative 3, right? And you add 2 to both sides there. So those are the two possible solutions for that particular problem, okay? So this is the idea. This is how we typically solve quadratic equations when we are working with algebra tiles, is that we try to arrange the left-hand side into a square, we try to arrange the right-hand side into a square, and then we describe the top of both squares, and we say that they must be equal to each other. So far, we haven't done an example where we've had to complete the square, because what we started with on the left-hand side here was already a complete square once we arranged the tiles appropriately. But that's not always the case. So let's look at another example where we actually have to complete the square in order to get the answer. Okay. So we're going to start off kind of similar, x squared minus 4x, but then we're going to say plus 2 equals negative 1. Okay. And let's see if we can solve this one. Okay. So I'll show you how this one goes. I'm not even going to ask you to pause the video. I'll give you another example here in a second that you can try out on your own. But let's just get x squared minus 4x plus 2. And I'm going to go ahead and arrange these tiles the way that I described on the previous example. Okay, so I put the x squared in the upper left-hand corner. I put half of my x's on the right-hand side and half of my x's below the x squared. And then what that leaves me is a cavity that I need to fill with units. Now, right now, the way that the equation's written, I only have 2 units. So as you can see, the square is incomplete. All right, on the left-hand or on the right-hand side, I have negative 1. Okay, so this is what I have to start with on step 1. Now here's what I'm going to do to solve this equation. So if I were writing this on the homework or something or on a test, I would copy this down, right? I would write it all out. And then in step 2, I would recopy what I had before. But now what I'm going to do is I'm going to complete the square. So in order to complete the square here, I obviously need 2 more units. And just like with linear equations, I'm allowed to add anything I like, as long as I add that same amount to the right-hand side. Okay. So now you see, now I've completed the square. Now I've got a complete square on the left-hand side. What I need to do is try to get a complete square on the right-hand side, and that's going to be hard to do when you have 3 tiles. Fortunately, these 2 tiles are a 0 pair, and they cancel each other off. And so I'm just left with 1 unit tile, which is already a square, right? So if I want to get the answer to this equation, I would say, well, so the top here is x minus 2. The top here is 1. So one possible solution would be x minus 2 equals 1. Another possible solution would be to say, well, this isn't a 1 by 1, it's actually a negative 1 by a negative 1, because that would still give me a positive 1 tile, right? So if that's the case, then I would have x minus 2 equals negative 1, and that's another possible solution. Most of the time with quadratic equations, you're going to have 2 solutions. Okay, so we finished solving. We say x equals 3 or x equals 1, right? So those are the 2 possibilities there. Okay, so now it's time for you to try one. I'm going to give you an example. You're going to have to complete the square in order to solve this one. Okay, so let's do x squared plus 6x equals 0. So I'll give you a second, pause the video, see if you can solve this equation by completing the square. Okay, here's my solution. So I'm going to start off giving myself an x squared, and then I need 6 x's. I'm going to arrange half of them over here to the right of my x squared, and I'm going to arrange the other half of them on the bottom of my x squared. On the right hand side, I have nothing, right? I have 0. So I don't have any tiles over there. This is what this would look like starting out. Okay, so this is x squared plus 6x equals 0. Now, to solve this by completing the square, this would be step 1, right? In step 2, I would copy this down again, and I would fill in what needs to be filled in this cavity here to complete the square. Obviously, I'm going to need a 3 by 3 grid in order to make that happen. I don't know about you, but to me, this is just very satisfying. Being able to make a square out of this stuff. Okay, so there we go. Not quite perfect, but that's the idea. Now, since I added 9 units on the left-hand side, I'm going to have to add 9 units on the right-hand side. Six, 7, 8, and 9. Again, I need to arrange these into a grid. I should have just drawn it, huh? Would have been quicker. Okay, good enough. So there we go. So I've completed the square here, and that allowed me to be able to make a square on the right-hand side. Now to get my answer, I have to be able to describe the top here and the top here. One thing to note as you're going through these examples is that the top edge and the left edge need to match, right? They need to be the same thing so that you have a true square. In this case, I have an x along the top and then 3 units along the top, right? So this would be x plus 3. And on the right-hand side, I have 3, of course. So one solution is that x plus 3 equals 3. Another solution would be that x plus 3 equals negative 3, right? Same reasoning as on the previous examples. So we finish solving for x, right? We would subtract the 3, x equals 0, or x equals negative 6. Okay, so let me just mention about when you're completing the square algebraically. Again, we said you take the coefficient on your x term, in this case 6, you divide it by 2, 6 divided by 2 is 3, and then you square that result and you get 9. And that's the thing that you end up adding to both sides in order to complete the square. Well, notice that that's exactly what we ended up adding. We ended up adding 9 units here in order to complete the square visually. But it didn't require us to think of any kind of like rule or something like that. We didn't have to memorize that fact. We just could tell, looking at the figure, that there had to be 9 units to fit inside of that cavity. But if you're thinking about, but why b over 2 squared? Why is that always the case? Then here's one explanation. We said that in order to arrange the tiles here into a square, we would split this number in half and put half of those tiles here and half of them there. So if you think about how many units that's going to create, right? Well, you're going to get 3 units going down this way and 3 units going across that way. That's going to make a 3 by 3 grid. So it's going to make a 3 squared grid that you have to complete. So I think that's really cool. I think it's a nice way that you can visualize what's going on. Whereas, back in algebra class, you might have just been told, well, just add b over 2 squared to both sides, and you have no idea why or what it meant, right? But this is why, right? This is why. I'll link you to another video that kind of explains this in a little bit better, I think, than the way I just explained it. But let's do one last example together before I link you to that other video. Okay, let's do x squared minus 2x plus 5 equals 8. I think you should be able to tackle this one on your own. You might have to be a little clever, because I think what's going to happen is you're going to end up with too many units this time, and you're going to have to get rid of some of them. That's okay. Anyway, give the video a pause, see if you can handle it. Okay, here's my solution. I'm going to do x squared minus 2x. So I'm going to put half of those x's here and half of them there. And then I have plus 5. So the 1 completes the square, but I have these 4 left over, right? That are just sort of hanging out, not really contributing anything. You could try to arrange them to make a square somehow. I don't think you're going to have very much luck, right? It's not gonna line up to make a square. And even if that worked, the top side here would be different than the left-hand side here, which you're not allowed to do. So I think what we're gonna have to do is just get rid of these tiles. Fortunately, we're allowed to do that, right? We can take away 4 tiles from the left-hand side as long as we also take away 4 tiles from the right-hand side. So let's give ourselves the 8 tiles that we're supposed to start with. 8. Okay. So there are 8 tiles now. Okay, so this would be step 1, right? This is the equation, just exactly the way that it's written here, represented in algebra tiles. Now step 2, I'm going to get rid of these 4. I don't need them. I'm allowed to do that as long as I get rid of 4 tiles from this side. Okay, so this is how things would look at the end of step 2. Now I'm in good shape on the left-hand side. That's already arranged into a square. On the right-hand side, I need to try to arrange these into a square. Seems like I can do it if I have a 2 by 2. Whoops. Okay, and there you go. The rest is history pretty much, right? The top of this, of the left-hand side looks like x minus 1. The top of the right-hand side looks like 2. So I'm going to say x minus 1 equals 2, or x minus 1 equals negative 2. And then we finish solving. X equals 3, or, oh, is that right? Yeah, I add 1. Here I add 1 and get negative 1, right? X equals 3 or x equals negative 1. Okay, that's all I'm really going to give you here. I should mention that we're just scratching the surface. We didn't look at any quadratic equations. For example, we didn't look at anything that like this. X squared plus 5x plus 6 equals 0 or something like that. The challenge with these ones is that your middle term is odd. So when it comes time to split the x's so that half of them are on the right-hand side and half of them are down below, ooh, that's going to be a little challenging because you're going to have to put 2.5 of them along the right and 2.5 of them down below. So for this particular kind of equation, I think that at some point the algebra tiles get in the way, right? And hopefully, you know, anyway, I won't ramble on anymore, but it would be difficult to do this one with algebra tiles. You could do it if you were drawing them out, but you would have to indicate that one of the tiles you're putting on is half of an x, right? So it doesn't work out too well. We also didn't talk about equations where you have like a leading coefficient different than 1. Oh, I'd have to think of one that we could even solve. 2x squared, I don't know. I'll just make something up. I don't know if this is even solvable using algebra tiles. But again, you know, you're going to have a challenge here arranging this into a square because you're going to have 2x squareds. And so I don't know if that's going to be totally possible to do, right? And then we also haven't talked about equations like this where, you know, you get to the equation, and let's say that I've given you some problem and you go to solve it and you end up with something that looks, oh, maybe I'll put the tiles on the page. Maybe you end up with something that looks kind of like this. So I don't know what equation you would have started out with maybe to end up with this scenario, but let's say you end up, but it is possible you could be solving some kind of equation and end up with a scenario that looks like this. Now, the left-hand side is arranged into a square. The right-hand side is not arranged into a square. This is a 2 by 1. which doesn't really work out, right? Because you could say, x plus 1 equals 2, but on the other hand, you could say x plus 1 equals 1, and how would you know which equation is correct? In fact, neither of them is correct, because the right-hand side needs to be arranged into a square. So what we typically do with these kinds of equations, these ones, we just have to draw a different kind of tile where we force the area of that tile to be 2. So we can say, well, if the top and the bottom, or if the top and the side are both the square root of 2, then the area would be square root of 2 times square root of 2, which is 2. Okay, so now you can say, okay, now the top and the side match each other. So now I can say x plus 1 equals the square root of 2, right? Or x plus 1 equals negative square root of 2. So that's the idea there. It gets a little bit janky, right, at some point. So I'm not really giving you a ton of examples beyond the ones that we've talked about. But at least, for equations like the ones that we've seen, right, completing the square works out pretty well as a method of solving. And I think it gives you a good visual understanding of that algebraic technique as well. So, okay, I'll link you to another video to talk a little bit more about the link between this visualization and the algebraic formula.